6, this is the last section in Chapter 6, which means 6.7 is review, and you have a test on Monday.
Why do you do that to us?
Monday.
Well, we're just
on Tuesday.
on Tuesday.
Okay, that's okay.
Then next spring break.
Next Tuesday?
Wait, we have a test.
No.
next Tuesday?
We have not had February yet.
Can't wait until spring break.
All right, so 6.6, we have volumes of solids of revolutions. Okay, so we are going to be talking about disks and washers. Disks and washers. Okay, so there was a question that was extra credit on the test about this concept. But basically the idea is that we're going to take a function. So in this picture, I'm not sure if you can kind of visualize what's happening here. Okay, but this equation is x squared. Okay, so if we take x squared, we bind it between, I'm not sure what it says, maybe 0 and 2. Okay, and we take it and we flip it around, so we revolve it around the x-axis to create a volume, a three-dimensional space. Can you kind of envision it? So it kind of looks like, yeah, like a cone. It's very coney. Okay. So the idea is that if I cut this piece right here and showed it at you, okay, so I cut this piece and I showed it to you, what shape would it create? A circle. Okay, so the idea here is that we're taking circles, and the important piece is that the radius of the circle is going to be the height of whatever the function is. Okay. So again, we have to make note of which axis we're revolving around. So if we revolve around the x-axis, we will be perpendicular to the x-axis, which means what kind of integral are we going to do? A dx. Okay, if we revolve around the y-axis, we're going to do a dy. Okay, so for our first example, they have this region that is bounded by y equals x squared and y equals negative x squared. It is also bounded between 0 and 1. So we are going to create the volume of the cross-section that is perpendicular to the x-axis. Okay, so the volume is, so we're going on the integral between which two x values? 0 and 1. And so remember that we're revolving this so that base shape is a circle, so I need a pi r squared. Okay, so pi r squared. The hard part here is that we need to figure out what the r is. Okay, so if I look very closely at the r is the distance between the x-axis and the top of this curve. You guys see where I'm referencing? Yeah. So the distance between here and here. So what is the distance between the x-axis and the top curve? 1. Okay, anywhere. So I need a function. This is somewhere on the function. What function is this? X squared. X squared. Okay, so my r is going to be x squared. Oops, that's not an x. Jeez. X squared. Okay, so my volume equation is going to be the integral from 0 to 1 of pi x squared dx. Yeah, and are we actually finding it?
No.
Yeah, I think we're done. I think it was just a setup. Okay.
It was just a warm-up.
It was just a warm. We're just getting warm here. All right. So basically it says here, the circular cross sections can also be formed by revolving very thin, essentially with no width, if you can imagine this, rectangles about the axis of revolution. So I said x-axis. These circular cross sections are more commonly called disks. Okay, so disks is a flat circle. Okay, the volume formed by revolving the region about the line that does not pass through the interior of the region is called a solid of revolution. The line is called the axis of revolution. Right, so the axis is just the x or y, so it's possible for you to like revolve it around maybe a y equals x. I don't think we're at that stage. That might be like calculus 2. All right, so all of our disk formula, big highlight here is, notice what they do in this equation. Do you see what's different?
No. Oh.
Look very closely here. They pull the constant out. Okay, so it is not necessary for you to pull the pi out. That's totally up to you. If you feel like you want to pull the pi out and deal with it last, fair game. If you want to keep it inside, it's not going to change your answer. Okay. All right, so question number 1 is going to be set up the integral for the volume of the solid that is now being revolved around the region. Okay, so our equation is x squared. We're bounded between 0 and 1, and we're going around the x-axis. Okay, so you can kind of see that drawing of the 3-dimensional shape. Looks very cone-shaped, maybe a little bit more warped than that. So what is my integral?
From 0 to 1.
Okay, so the only difference is that they pulled the pi first. Again, up to you. 0 of 1, what is my r? X squared. So we're going to go x squared, squared. Don't forget the squared. There's a lot of squares there. Squared, squared, dx. And don't forget the dx, meaning we're revolving around the x-axis, our functions and terms. Yeah, so the warm-up was doing more of like taking the rectangular, so maybe making it less, I don't know, less complicated. I don't know. I think example number 1 is, I think you're there. Yeah, I think that makes sense. That actually makes more sense to me, personally. All right, let's try another one. All right, so number 2 says, find the volume of the solid formed by revolving the region in quadrant 1. Okay, so it's going to be bounded by the equation y equals x squared. X equals 0, y equals 4, and we're going around the y-axis this time. Okay, so first thing I want to do is draw a very accurate sketch. Okay, so if I draw x squared only in the first quadrant, we're going to start at 0, 0. It'll go through the point 1, 1, and 2, 4. Okay, so trying to kind of draw that there. Okay, x equals 0 is where? Okay, it's the y-axis. Okay, so there's the y-axis. And the equation y equals 4 is what? Horizontal line up 4, good. Okay, so you can see that bounded region, okay, kind of right here. And we're going to take this region and we're going to revolve it around the y-axis. You see my little revolving line? Okay, so can you kind of imagine what this shape looks like? It's kind of like a bowl.
Yeah.
Like a tall, maybe boss. Anyway, okay, so vase, boss, same thing.
No. Not that.
Boss water?
Boss. No, that's how you say it when it's a fancy vase. It's boss.
Is that like French?
I was just kidding. That was kind of a joke, but you guys didn't get it. Okay. Anyways, we're revolving around the y-axis. So we're going to throw out a pi in the front, right? Okay. So notice that we're doing a dy here. Okay, so that means my bounds have to be in terms of y. So we're going vertically here. What is my a and b value? 0 to 4, right? 0 to 4, so we're using y values. Okay, my equation that we're using is y equals x squared. Okay, but y equals x squared is an equation that's in terms of x. I need an equation that's in terms of y. So what do I need to do here?
Y squared.
Okay, so good. X is equal to the square root of y, technically plus or minus version, but we're working with the first quadrant, so therefore we're just working with the positive. Okay, so we're going to have the square root of y. Make sure we are doing pi r squared, so our square root of y is squared. And then we need to say dy.
So just y.
Yep. Now this one does say find it, so we're not just setting it up, we're actually going to do this. Here we go. So first thing I'm going to do is simplify. The square root of y squared makes y. We're just simplifying. So now I'm going to integrate. The integral of y is 1/2 y squared. We're going from 4 to 0. Okay, so now we're going to plug in a top minus bottom. So if I plug 4 in, I bet we could probably do this mentally. 4 squared makes 16. Half of 16 is 8. And what happens if I plug 0 in? You get 0. So the volume of this revolved is 8 pi units, whatever it happens to be in. What's that? Yes, units cubed. Yes, you're right. Okay. Pretty good at that one, right?
Yeah.
All right. So the second scenario here is that we have a washer. Okay, so a washer, you guys know what a washer looks like, right? Okay, so you have an outside circle and you have an inside circle cut out. So there's a gap that exists around your line of revolution. Okay, so make sure you highlight that washer one. It's a big R minus little r. And the reason they say big R minus little r is because the big R is representing your furthest height and your little r is your not so far away height or distance from your revolution line. So it does say big R is your outer radius, little r is your inner radius. Okay, so 3, we're just setting this up. Okay, we are revolving the equation negative x squared plus x and y equals 0 about the x-axis. So they've drawn question A. Do you guys have the same picture that I do?
Yeah.
Okay, so we're revolving it around the x-axis. So is this a washer or a disc? Okay, yeah, okay, so it says the word disc there. But do you see why it is a disc as opposed to a washer? Okay, so anytime the area, if we're revolving around the x-axis, if the area that we're revolving around is touching it, then it's going to create a disc. There's not going to be any separation. As opposed to B, where this one is revolving around the y equals negative 1 line, so you can see this area has a gap between that line of revolution. Okay, and that's what creates the washer scenario. So this would create a washer because you're revolving it around this line. So if I take this area and revolve it, there's a gap between here that's empty. Yeah.
Please excuse the following students to the office for the hearing pre-screening. Yusuf Ledesma, Mia Bardeo, Paige Furman, Coulter Keith,
So,
Ava Grant,
dx or dy here?
Garrett Tessner, Ashley Morgan,
Dx.
Sadie Ashton, Emily Sullivan, Tegan Gussie, Taylor Adams, Shayna Smith, Riley Gunther, Jackson Peterson, and Sophie Brandmeier. Thank you.
Okay, so integral between what two x values? 0 and 1. Oh, I forgot my pi in the front. I always like to put the pi after. I don't know. It helps me remember the r squared. I don't know. Anyways, my r value for this one is what's the equation? So what is the distance to that line from the x-axis to that parabola? There you go. Negative x squared plus x squared dx. Okay, so that's your question A. Okay, now doing a washer is a little bit more intense because you have to figure out the distance between the equation and your line of revolution. Okay, so for B, they're asking us to revolve it around y equals a -1. So this y equals -1 is right here. You guys see that line?
Yeah.
Okay, so I have to do a big R minus a little r. Okay, so for my volume, we're still going to do a pi first. Okay, the integral still exists between 0 and 1. Okay, so my big R, go fast. Okay, my big R, can you tell me what the distance between this -1 line is and the top of the parabola? What is that entire distance?
About
Well,
1 minus 2 5 years. Oh, it's a negative x.
so you probably do that
No, it
equation
is.
with that
Okay, good.
equation.
So yeah, so basically it's the same distance as this, right? So this little distance was -x² plus x. But then I also have to include one whole unit to get to that line. Okay, so my big R is -x² plus x plus 1. Is everybody okay with that? Squared. Okay, and then I have to subtract out the little r. Okay, so the little r is the distance between my line of revolution and the x-axis. Okay, that one is always the same. It is a constant, and it is a distance of 1. Good. So -1. Okay, so then we say dy. And I always like to put like big quotes around that so that in the end we're dx. I don't know why I wrote y. I was my bad. I was thinking about the y equals -1 dx. Thank you. All right. So question number C, same idea as question 2, but this time my line of revolution is up here. Okay, so my big R is going to be a little bit different. Okay, we have a washer. Everybody okay with that? It does say washer. I kind of spoiled that fact. Okay, so we're going to do the big R minus little r. So we have pi. We're still going from 0 to 1. Okay, so the big R is the furthest distance from my line of revolution to the bottom of this area, okay, which is essentially the x-axis. So what is the distance from y equals 2 to the x-axis? 2. 2. And it's always 2. It doesn't change. So we're going to say 2 squared minus. Okay, so now my little r is going to be the distance from my y equals 2 line to my parabola. Okay, and this does change, so it's going to be in terms of x. So what is that distance?
Probably like
Good. So for this one, we're going to have a height of 2, but we subtract out this little distance below the parabola. Okay, so my little r is 2 minus -x squared plus x. Okay, now when we do this, we have to be really careful because it's 2 minus an equation, -x squared plus x. You see how that can be really scary with that negative? Yeah, all kinds of parentheses going on. dx. Okay, so make sure that you are distributing this negative to the quantity. We also need parentheses for squaring because it's little r squared. And then we need a big set of parentheses because all of this is being integrated. Everybody okay with that one? Good. Big R minus little r, okay? Okay. All right, so we got another one. Set up but do not integrate. I love these ones. Okay, so this one we now have 2 functions that bound our region. Okay, so when we do this one, we want to be thinking top minus bottom for our distances, right? Okay, so the first question, A, is revolving around the x-axis. Okay, so my first question to you is this a disk or is this a washer? Okay, so remember, a disk happens when the entire area is always touching the line of revolution. So is this area always touching my line of revolution?
No.
Not always, right? So therefore, we know that this is going to create a washer. Okay? There will be one instant at x equals 0 where it creates a disk, but that will be kind of sucked up into the washer equation. Okay, so this is a washer, so I need a big R minus a little r. Okay, so are we doing a dy or a dx? Dx, we're revolving around the x, so it's a dx, so we're going to go, the volume is, oops, I forgot my pi, I always forget my pi. Pi, okay, what two x values are we bound between?
-1 and 2.
-1 and 2. Now, we are assuming that is a true fact based on this graph. Do you believe that this is graphed correctly, or should we double check by setting the two equations equal to each other?
I trust them, I'm sure it's fine.
Okay, so be careful on your assignment or on a test, okay, that you verify that that bound does in fact go between -1 and 2.
So we just set them equal.
Okay, it is true, yes. And we can do that. X squared is equal to x plus 2. We could do a little prove it just for practice. Set it equal to 0. Two numbers that multiply to -2, add to -1 are -2, +1. So the two values are 2 and -1. Okay, so we are correcting that assumption. All right, so now here comes our big R minus little r. You ready?
No.
Oh no.
Okay, so the big R, remember, is the distance from your axis of symmetry, or axis of revolution, to the furthest spot. Okay, so the furthest equation is the linear equation, right? Okay, so which one is my linear equation? X plus 2. Okay, so we're starting with x plus 2 squared minus my little
Can I
r.
have T and Debbie to the office, please?
She's not here today.
Oh, okay, thank you.
Okay, so minus my little r. So my little r is my shorter distance to the area. Okay, so what's that one? X squared. So minus x squared. And don't forget your squared. Dx. Everybody okay with that one?
Yep. Wait, that's all we do?
Yeah, because it just says setup. The nice thing about this is that they kind of make it a little easy on you and work on setting it up and then integrating it. Okay, so B, we are now going to take this area and we're going to revolve it around the y equals 4 line. So y equals 4 is this line way up here. Okay, so again we have a washer. There is a big gap right here in the area. Okay, so we know that it's a washer. It's not always touching. So we're going to go the volume of pi from -1 to 2. Okay, and we have to start with our big R. Okay, so the big R is going to be the furthest distance from my line of revolution to the end of the area. Okay, so in this case, the end of the area is the parabola. So what is the distance from this line of 4 to the end of the parabola? 4 minus x squared. Okay, so we start here and we'd have to subtract out whatever the height of that parabola is. Okay, so my big R is 4 minus x squared. Everybody okay with that?
Yeah.
Okay, so big R squared. Don't forget the big R squared. Now minus the little r. So my little r is going to be the closer distance. So now we're talking from the line of revolution to the linear equation. So what is the distance from 4 to that linear equation? Okay, good. So 4 minus, and again, be very careful of parentheses. 4 minus x plus 2. If you want to distribute the negative through and lose your parentheses, that is okay to do. But I'm going to write it just so you can see exactly what I'm doing. All right, pretty good? Should we read any of this? Perpendicular. Remember perpendicular. All right.
And we averaged a 3.59.